This is my favorite fifth period class. I look forward to having it every day.
Me too.
Me too. Well,
This is my favorite class.
this is a good class period.
This badger should stop.
Okay. So 18. 2 cotangent 2x would be the same thing as, 2 over what? Or 2 times 1 over what? 1 over tangent 2x, right? Oh, let's see if we have a cool formula we can replace tangent 2x with. Oh, we do. We do. We could replace this. Oh, now, if it's 1 over that, isn't that the reciprocal?
Yeah, that is correct.
So couldn't we do, instead of, so that would put the 2 tan x on the bottom instead of the top, and the 1 minus tangent squared on the top instead of the bottom. All I'm doing is using my formula, and I flipped it upside down. I flipped it because it says right here we want the reciprocal. Okay, so that's what I did. I looked at it in the book or on my formula sheet or in my notes, and I said, hey, I'm going to flip that thing over. Mm-hmm. Okay. Whew, I see some serious mitosis coming here. All right. Hold on to your hats, folks. This 2 is going to slide out over here. Okay? Have you ever seen those mobile homes or RVs with the pop-outs, the slides that just like suddenly their living room comes out, you know? That's what just happened with that 2 right there. Okay? It's a pop-out. All right, so we have 2 over 2. And then we have 1 minus tan squared x over tan x. Okay. So far, do you see anything that cancels? 2's gone. All right. Can you split what's in the parentheses into 2 fractions with the same denominator? What would they be? Woo! 1 over tan x minus tan squared x over tan x. Really? Nicely done. Well said. You said what? Okay, did you do it a different way?
Yeah. So
Let's see. Oh, I see. You used the cosines. Okay. Did it work out smoother than this? It did? Okay. So maybe I can look at it that way too. What is 1 over tangent x? That is cotangent. And do any of the tangents cancel? One of them does, leaving one left. So we're done. We finished the proof. Okay, we got all the way to the end. So the alternate way to do that would be to use, so you used cosine 2x over sine 2x. Is that what you did?
no, so cosine x over sine x minus sine x over cosine x. Then.
I see. You started on the right side and worked your way back to the left. Oh, little dirty trick there, man. He's trying to work the opposite direction.
He's the dirty bird.
I'm not sure. I'd have to think about whether I would buy that. But, it's possible I would buy that. Okay? Anyway, that's what I would do for question 18. Then you wanted question, the only problem with writing those over on the side is I'm going to delete them here in a second. All right, well, we'll just have to, here, I'll put it on paper. That won't get erased. Okay, so I want a 22 and a 26 and a 34. 14's in the video. Hopefully you can watch that one. If you still have questions about it, I'll be happy to answer it. But all right, next, 22. Oh man, that's a bad looking sign. Sine 4x. And we want to change that into 4 sine x cosine x times 2 cosine squared x minus 1. Whoa. Okay, I'm going to split 4x into 2x plus 2x. What's that give me? Well, I can use the sine sum formula. Isn't that the one that was like y, x, same sign, x, y? Okay, so y of the first angle, x of the second angle, plus x of the first angle, y of the second angle. Now, you don't have many choices for what you're going to replace sine 2x with, do you? All right, we know what we're going to replace that with. 2 sine x cosine x. But the better question is, what are you going to put in there for cosine 2x? We need to look at our answer to give us a hint. We need to look at our answer to give us a hint. Now, obviously, we should pick the same thing, right? But I think the hint is sitting right there. So what should we replace cosine 2x with? 2 cosine squared x minus 1. 2 cosine squared x minus 1. Well, I know those look like gigantic terms, but do you realize those are both like terms? If you have 2 of these things, which I know we do because it says we do right there, and we have 2 of these things, I know it is because it says right there, how many of them do we have total? We have 4 of them. Isn't that the end? They're like terms. I know they're gigantic, but they're like terms. Yes.
So why are only 2
Okay. Suppose, okay, if you want me to start using letters, suppose we call sine, let's call it W. Cosine, we'll call it U. Cosine squared minus 1, we'll call it F. 2 wolf. I don't know, I'm just making this up. All right. Guess what? We got a 2 wolf over here too. If you got a 2 wolf on one side and 2 wolf on the other, don't you have 4 wolves? Then hopefully you don't get eaten. Like if you go out at night and there's a whole bunch of wolves, you know, I'm like, they will sneak up on you. Okay, you don't want to let your animals out at night, you know, when you're not, especially not around here.
What if it's a lion?
Possibly, yes. I think that, you know, that cat will be okay. Unless there's a lot of them. Okay. So I know that's a giant mess, but you're really just, there's 2 of this and 2 of this, so that makes a total of 4 of them. And since that's what they were looking for, we're done with that proof. I know. It was pretty cool. That was 22, right? 22. See, that wasn't as bad as you thought. 26? It was? Sometimes it really do be like that. Solve algebraically for exact solutions in the interval 0 to 2 pi. All right. Sine x plus sine 3x. Okay, now, I here do solemnly swear that I'm not going to throw a sine 3x at you, I don't think, because it's going to be, it's going to make a mess. Oh, what's it equal to? I forgot. 0? Okay, cool. Sine x plus, we have to do this, folks. X plus 2x. We have to split the 3x up into x plus 2x. We must use the sine sum formula. Now this first sine x that's sitting out here is just going to be lonely for a second. Okay, until we figure out what's going on in here. We'll use our sine sum formula. What was it? Y of the first times x of the second. Same sign. X of the first and y of the second. Sound like what? I know. This is what separates the math teachers from the rest of the world. We do have fun when we do these things. Okay. Now, let's see. What are you going to substitute for this one right here, sine 2x? Isn't that 2 sine x cosine x? And if I multiply that times cosine x, what does that become? 2 sine x cosine squared x. Okay. Yep. 2 sine x cosine x, that's your sine 2x. I just was multiplying it times cosine x. That's where we got the cosine squared from. Now, I'm going to ask you to use your night vision goggles. And I want you to see something in all 3 of these terms. Do you see that in all 3 of those terms? The green box. Do you see the green box? That means I'm going to be factoring that term out. Okay? That's going to get pulled out. What is this red one going to be left with if I pull out that sine x? 2 cosine squared, right? Now that is giving me a clue, folks. That's giving me a clue about what I think I should be replacing this with. What? Because you remember, cosine 2x is the one you struggle with because there's 3 options. So what are you going to put in there? What is your gut telling you? The 1 minus 2 sine squared? I don't think we should do that. I think that last term is giving me a different clue. The 2 cosine squared minus 1. So I'm replacing this one with 2 cosine squared minus 1, x squared, cosine x minus 1. Okay? That's what it says right here. Oh my goodness, we're using it a lot, aren't we? Oops. Okay. Questions? Ask them before we move on. Okay. The last term, we replaced this sine 2x with that thing right there. We multiplied it times the cosine x, and that's how we got this part in the red down there. We replaced this cosine 2x with 2 cosine squared minus 1. Every one of these terms has a sine x in it, so I'm getting ready to vacuum it out right about now. Okay? So if I pull the sine x out, what will I have left? If I pull it out of this first term, what am I going to have left? 1 plus 2 cosine squared x minus 1 plus 2 cosine squared x equals 0. All I'm doing is factoring, folks. I'm taking that box out of each one of those terms. Now, can we combine any? Yes. That's what I was getting at. To try to tell you, when I saw this over here, that since I knew I was going to be pulling out the sine x, the only thing left in that last term would have been cosine squared. So that's what led me to think, hey, I should replace cosine 2x with something that only involves cosine squared. Because when you look at the parentheses at the bottom, can you tell me anything that cancels out? Ah, the ones do, right? 1 minus 1 is 0. Are the other two like terms that I can add together? Sure thing. So we have sine x times 2 cosine squared x. Or no, not 2. Duh. 4. Can't believe I said that. Yes. Yeah. Hey, it's funny. Yes.
I'm just trying to say it like a Harvard student.
Oh, yes, yes.
No.
Okay, maybe next week.
Yeah.
Okay. Depends on, or just drive if you want to go. All right, now, do we have it in factored form? The red one at the top, do we have it in factored form? Well, we definitely have it in factored form because we have two things that multiply together to give us 0. So one of those things has to be 0. Either sine x is equal to 0, or 4 cosine squared x equals 0. We need to find the solutions that come from that. Okay? So, man, I'm running out of room here. Gonna have to erase. Give me some space. Well, as I told you a few minutes ago, I don't think I'm going to put a sine 3x on there. That 3x caused a lot of extra work. Possibly. Okay, sine x equals 0. Where are the solutions for that? 0 is definitely one of them, yes. But what else? 0 and pi. Okay. And then cosine squared. So if I divide that thing by 4, I get 0. If I take the square root, I get 0. So that all boils down to cosine x equals 0. And if cosine, which is an x value, is 0, that happens...
Pi over 2 or 3 pi.
Yeah, pi over 2 and 3 pi over 2. 4 answers there. Yes, Miss Johnson. Yes. Because typically in the problems it'll say this. It'll say your answers have to be between 0 and 2 pi parentheses. As soon as they throw that parenthesis on there, they've taken that option out. I do understand what you're getting at, though. They just want to know in one complete revolution how many solutions there would be. Every revolution would generate 4 more solutions. Because I divided by 4. 0 divided by 4 is still 0, right? Take a square root, I still get 0. So I know I didn't show that, but we mentioned it out loud. All right. That's pretty cool. All right, then you wanted 34. Man, don't we get a half angle in here somewhere? Ooh, 34. Nice. Amen to that. Okay, 34. 5 pi over 12, what is that in degrees? 5 times 180 over 12? Isn't that 75? Okay, so this is the sine of 75 degrees. Okay?
That's it?
Oh, no. Don't say that's it, because we have to use the half angle formula to figure it out. Okay, now, one of the ways we did this in section 3 was we took things like 30 and 45 and 60 and 90, and we started either adding or subtracting them. But they didn't ask me to do that. They wanted me to do this with a half angle formula. So, can you tell me, why didn't that write? 75 degrees is what over 2? What over 2? 150 degrees over 2, right? So when you go to use the formula, the half angle formula, you better be using 150 degrees. Now 75 degrees. Remind me, folks. 75 degrees is, I don't know, somewhere up here, right? Approximately? Can you tell me if that has a positive y value or a negative y value? Definitely positive. Now, you know in the formula how it says plus and minus? They're forcing you to choose which one it is. All you have to do, based on where you think 75 degrees is say, that has to be a positive. Okay? So don't put plus and minus in front of it. Choose one. All right? Then there's some cool formula, isn't there? Well, yeah, I would. 1 minus cosine what? 150. Folks, all I have to do is take this number and throw it in the formula. Don't take the 75 and throw it in the formula, because that'll screw you up. The formula in the blue box that says sine u over 2. I'm looking at the one that says sine u over 2. Okay? Now, do you know the cosine of 150? 150 is over here. Cosine is an x. What is that x value? It is not positive radical 3 over 2. It is negative radical 3 over 2. So you have the right number. Okay, so we have 1 minus negative radical 3 over 2, all divided by 2. Boy, that looks like a complex fraction. We should simplify it.
If you want to.
You say we leave it alone. See what the red pen of death says to you. Okay. When you got that double negative in the top, what happens to that? Makes it positive, right? Okay. 1 plus radical 3 over 2. Now, division by 2 is the same thing as multiplication by what?
1/2.
1/2, the reciprocal, okay? So, we got the same thing going on right there, right? Division by 2, same. Or you could think of it like this. You could say, what if I multiplied the bottom by 1/2 and the top by 1/2? Isn't that the same result? Either way you want to look at it. So let's see here. If you multiply that 1/2 inside there, what do you get? 1/2. Yes, right, because you multiply 1/2 times 1. Times, or plus, I should say, radical 3 over what? That's an acceptable answer there, folks. You could. Okay. All I'm getting at is there's another form of that as well. How about 2 plus radical 3 over 4? You could get common denominators and put them together if you wanted to. That's another acceptable answer. Do you guys know the square root of 4? Okay, so if you were like, if you really wanted to, you could do this. That's another acceptable answer. Over the top. Well, that's how you get promotions, recommendations for jobs, things like that. No, you will not get kicked out of party. I mean, probably, another free non-alcoholic drink. That's what I'm saying, but okay. It's an interesting thought. The red pen of death does pay currency in credit. You're right. Yes. 30?
How do you use a graphing calculator for that? Number 30 is a problem. That's not bad.
We'll find out what we're at. 30. They actually want me to graph the two functions and see where they intersect. I'm going to guess that 30, well, you know what, I'm going to look at it, but it might get pretty ugly. So I'm not going to ask you a graphing calculator question. So if this gets ugly fast, I'm going to abandon ship and go straight to the 38A, use the identities to prove that. Oh, that was kind of a slightly lame question in my opinion. It wasn't very, although, so sine 3x, this is the one I said, anything with a 3x is going to cause you some difficulties because it's going to be sine x plus 2x, and then you're going to have to go through the process of, y of the first times x of the second plus x of the first and y of the second, and then plus cosine 2x. Okay? And they want to know when this thing equals 0. I forgot. Equals 0. So, let's see. What do you want to replace? Well, sine 2x, that's pretty easy replacement, right? And so we know that's going to be 2 sine x cosine x. And so if we replace that one and simplify that middle term, turns into 2 sine x cosine squared x. So some of you are now saying, okay, what the heck am I going to substitute in for cosine 2x? Because, we have 3 choices, right? I think this is going to get messier than we want. But I really think that you would, so there might be a few substitutions that we would do. It's possible that I would replace these with both 1 minus 2 sine squared, 1 minus 2 sine squared, it's all about which road is the easiest one. So if you kind of get my drift, what do you think I'm going to replace that cosine squared with? One minus sine squared. So this is getting to be a lot of substituting, right? Quite a bit, actually. Because but you know what? There's going to be like terms here. We're going to factor. There's no way I would be throwing this question with this much work on a quiz or a test for you guys because of that 3x issue. Okay? If you can handle this in the homework, and yes, there's lots of steps. I do understand that. For instance, if I distributed that, that would be 2 sine x minus 2 sine cubed x. Over here, sine x minus 2 sine cubed x. You start seeing like terms, and then you got your 1 and your minus 2 sine squared x. However, what I don't like about this, okay, so if I start circling my like terms, we got those two, right? We got that one right there by itself. Boy, this is a nasty one. You got the 2 sine x's right here. I was hoping for a sine x that I could pull out of all of them, but why is that not going to happen? Because of that one right there, the plus 1. This is a cubic polynomial? Yeah, there's no way I'm throwing this at you. No way. So we'll stay away from the sine 3x issue for quizzes and tests here, because it does create a lot of extra work. Okay. I think we should look at the review sheet. 38. 38's not as bad as you think. Use the identities in 37. So they want you to go up above and look at it. So we know that tangent squared is sine squared over cosine squared. All right. So if I go to the ones up above and I just replace it with these and these, okay, if division is the same as multiplication by the what? Reciprocal. So we take the second one and we flip it over. Anything cancel out? So you're done with this proof, because those 2's canceled out. So it's really not, not too strenuous of a proof. That makes sense? Okay. All right. Jump over to that. Yes. Sure. Is it there? Is it here? Yeah, here it is. You can, yeah. Smart idea. Oops, I should. So we decided it was a cosine because it was at. Oops, sorry, don't move that. Because it was x, y, y. Okay, that's why it was a cosine. We used the opposite sign, and we subtracted with our brains. And got 112 minus 45 is 67. Okay, so that's all that question was. Well, yeah, that's because it says write the expression as a sine, cosine, or tangent, just like the ones we did in class when we practiced together. Yep. It's in the video. Whatever we get through today. I mean, pause it whenever you need to pause it. It's like a slow moving, the movie credits at the end of the movie. Dun, 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 dun. Yes, this is after lunch, and the children are doing random things. Wow, question 8's a mess. Random sounds by students in my room.
doing this speed test thing.
Doing a what test?
You're an octopus.